All right, let's talk about caching. We all know it's this incredible tool for making our systems super fast, right? It's like this secret weapon for high-performance apps. But what happens when that weapon backfires? Well, it can take your whole system down with it. So today, we're going to dive into the 4 big ways your cache can turn against you, and more importantly, what you can do about it. Okay, here's our game plan. We'll kick things off by looking at the basic weakness of any cache. Then, we'll get into the main event, the thundering herd problem, cache penetration, the hotkey breakdown, and the dreaded total cache crash. We'll wrap it all up by talking about how to design a truly resilient caching system. So, let's start with why caching is even a thing. I mean, it's basically the hero of system performance, right? It sits there, holding on to data, saving our poor databases from getting hammered, and making users happy with lightning-fast responses. But every superhero has their kryptonite. And for caching, its biggest strength, well, that's also its Achilles heel. And this quote right here just nails it. A cache is this awesome temporary storage, but it's also a single point of failure. Think about it. You've got this high-speed shield protecting your database. But what happens if that shield just vanishes? Poof, gone. Suddenly, every single request that was being handled by the cache is now rocketing straight towards your database. And that's how a small problem turns into a total system meltdown. All right, let's meet our first horseman of the cache apocalypse, the thundering herd. This one is a classic, and it is every bit as destructive as it sounds. It's all about what happens when everything goes wrong at the exact same time. This analogy of a dam breaking is honestly the perfect way to picture it. Normally, your cache is that strong, sturdy dam. It holds back this massive river of user requests and just lets a calm little stream flow through to the database. But with a thundering herd, you don't get a leak, you don't get a crack, the entire dam just explodes. So what's the trigger? What causes this catastrophic failure? It's simple, really. A bunch of keys all expiring at the exact same time. Imagine you set up your cache to refresh a big chunk of data every hour, right on the dot. So at 2 p.m. sharp, boom, all those keys are suddenly invalid. The next 1,000 requests that pour in, they find an empty cache. And what do? They all stampede to the database at the same instant to try and get the data. That's your thundering herd. And just look at the impact here. It's absolutely insane. We're not talking about the database load doubling or tripling. No way. It can spike by orders of magnitude in a fraction of a second. Your system goes from being perfectly fine to completely overwhelmed, often so fast your monitoring systems can't even raise the alarm before it's too late. Okay, so how do you stop a stampede? Well, the solution is actually pretty elegant and surprisingly simple. It's called jitter. Instead of setting every key to expire in, say, exactly 1 hour, you add a little bit of randomness. So one key might expire in 59 minutes, another in 61, another in 60 minutes and 30 seconds. This tiny change staggers the expirations. It breaks up the herd. And just like that, your catastrophic flood becomes a calm, manageable trickle again. Next up, we've got a different kind of beast. This one isn't about keys expiring. It's about asking for data that doesn't exist, and never did. We call this cache penetration. Or as I like to think of it, you're basically sending your system on a ghost hunt. Yeah, this librarian analogy is perfect. Imagine you keep asking the librarian for a book that was never published. The first time she searches the whole library, the second time she does it again and again. It's a total waste of her time. It's the same for your system. A request comes in for a bogus user ID. The cache says, nope, not here, so it goes to the database. The database does a full search, finds nothing, and says, sorry, doesn't exist. And then another request for the exact same bogus ID comes in, and the whole pointless, resource-intensive cycle starts all over. So the key here is that the data doesn't exist in the cache or the database. And this isn't always an accident or a bug. This is actually a really common way to attack a system. A hacker can just flood you with requests for tons of random fake keys. They know these requests will bypass the cache every single time, hammering your database directly until it just gives up. Luckily, we've got a couple of really clever ways to fight this. The first is super straightforward. Just cache the null result. When your database confirms that some data doesn't exist, you just store that fact, the null, in the cache for a few minutes. Problem solved. The next request for that ghost key gets stopped right at the cache. The other, more advanced option is something called a Bloom filter. Think of it like a bouncer at a club with a really good memory for people who've been kicked out. It can't tell you for sure if someone is on the guest list, but it can tell you with absolute certainty if someone is not on the list, saving you from even bothering the database. Okay, on to our third horseman. Now this one, the hotkey breakdown, might feel a little bit like the thundering herd we just talked about, but trust me, it's way more focused and, in some ways, even more dangerous. This is what happens when your one single most popular item in the cache just vanishes. So, what's a hotkey? Think about the single most popular thing in your system. A viral news story, a celebrity social media profile, a product that's flying off the shelves. It's not crazy for a single hotkey like that to be responsible for like 80% of your total traffic. Now imagine what happens when that key expires. You've just redirected the vast majority of your traffic straight to your database. So see, that's the big difference from a thundering herd. A thundering herd is when thousands of different keys expire. A breakdown is when just one key expires. But because that one key was the star player, the result is identical. A huge, focused blast of requests hits the database, all demanding the same thing, all at once. And the solution for this one? Well, it's kind of beautifully simple. If you have a piece of data that is so important, so hot, that your whole system depends on it, just don't set an expiration time for it. Period. Make it a permanent part of your cache. You can still have a process to update it when it changes, of course, but you never, ever let it disappear because a timer ran out. And that brings us to our fourth and final horseman. This is the big one, the one that keeps engineers up at night. What happens when it's not just one key or a bunch of keys, but the entire cache service itself just dies? Your whole safety net is gone in an instant. Doesn't matter how it happens. Could be a network issue, a bad deploy, a server catching fire. The result is always the same. That protective shield you had between your users and your database, it's just evaporated. And now, every single request, 100% of your traffic, is flying directly at a database that was absolutely not built to take that kind of punishment. So what's the defense plan? You've got two main options here. The first is a safety measure called a circuit breaker. It works exactly like the one in your house. It senses that there's a dangerous surge of traffic about to hit the database, and it just trips the switch, stopping everything to prevent the database from blowing up. The better, more proactive solution, though, is to build a high-availability cache cluster from the start. That way, if one cache server fails, another one is right there ready to pick up the slack instantly. No single point of failure. Phew! So there they are, the four horsemen of cache failure. And I think the big lesson here is pretty clear, right? You can't just design your cache for sunny days and perfect performance. You have to actively design for when things go wrong. So let's pull all these solutions together into a kind of defense plan. And here it is, your resilience checklist. Seriously, thinking about this stuff from the beginning will save you so much pain later. So you're going to want to add random jitter to your expiry times. You'll want to cache null values or use a Bloom filter to stop those ghost queries. For those supercritical hotkeys, just make them permanent, no expiration. And finally, build in your safety nets, implement circuit breakers, and if you can, run a high-availability cache cluster. And that really brings us to the final question you should be asking yourself. It's easy to build a cache that makes your app feel fast when everything is running smoothly. Anyone can do that. But a truly professional, resilient system, that's one where the caching strategy is built for survival, for when things, and they always do, inevitably go wrong.